Hi there, and thanks for tuning in. Today we're going to be looking at Lesson 2.6, Solving Absolute Value Inequalities. Much like we solved absolute value equations, we are going to be writing two different inequalities to solve, and you're going to see some things change, so just keep that in mind. We're going to be writing down 7 things in our notes today, so let's go ahead and get started. First thing we want to know is what happens when we solve absolute value inequalities. So for the first one, it says to solve the absolute value of ax plus b when it's less than c and c has to be bigger than 0. That's an important part. You're going to solve the compound inequality ax plus b is greater than negative c and ax plus b is less than c. So notice we kept it the same for one of them, and then we just switched the inequality symbol and the opposite of the number. The same thing was going to happen here in this yellow highlighted one. Again, c still has to be greater than 0, but one of them will be the same. Ax plus b is greater than c, and one of them will change. Ax plus b is less than negative c. So you're essentially switching the inequality symbol and the opposite of the right side's number or numbers. Okay, we're going to pause here so you can write down both examples. So here and here, and then once you're done, click play so you can see how it's done. Alright, so here are 2 examples. The first thing we're going to do is go ahead and solve letter A. Remember what you just wrote down. The first thing we're going to do is change it so that we're switching the inequality symbol and the number to the right will be its opposite. So the first thing we'll switch, we'll say x plus 7 is greater than or equal to negative 2. But the other one will just be the same. X plus 7 is less than or equal to 2. I'm going to go ahead and solve both of these. So I'm going to subtract 7. So for this one, I'm going to get x is greater than or equal to negative 9. And then over here, I'm going to get x is less than or equal to negative 5. We are going to graph it to see if it overlaps. So here's negative 9 and here's negative 5. Negative 9 is a closed circle pointing right, and negative 5 will be a closed circle pointing left. So they do overlap. So this would be considered and because they're overlapping. So I'm going to write it as an and inequality. Negative 9 is less than or equal to x, which is less than or equal to negative 5. So here would be my answer for letter A. Okay. For letter B, if you notice, 0 cannot be solved because 0 isn't greater than 0. So then remember the expression has to be greater than 0. If you look back here, c has to be bigger than 0 for both of these. And 0 is not bigger than 0. So we're going to say no solution for letter B. Okay, so just be careful with those if they're not greater than 0. Here are 4 that you're going to try on your own. So let's go ahead and pause the video here. Take your time in trying them. And once you're done, click play to see your answer. So for number 2, we will have x is greater than or equal to negative 3.5. Again, switching that first one. And then the second one is still the same. X is less than or equal to 3.5. They're already solved for us, so what we're going to do is just graph it. So we're going to start with negative 3.5 and see if it's an and, see if they overlap. So I'll have a closed circle for negative 3.5 going right, and positive 3.5 closed circle going left, so they do overlap. This will be an and. So negative 3.5 is less than or equal to x, which is less than or equal to 3.5. Okay. For number 3, I have k minus 3 is greater than positive 1, but right before I solved it, I realized that this number is not greater than 0. So for actually number 3, I'm going to say there is no solution. Because once again, this number has to be greater than 0. Okay. For number 4, though, I believe I can solve that one because 11 is bigger than 0. So I'll have 2w minus 1 is greater than negative 11, and then 2w minus 1 is less than 11. I'm going to go ahead and start solving by adding my 1. So I'll have 2w is greater than negative 10. So that means w is greater than negative 5. And then over here, when I add 1, I get 2w is less than 12. So w is less than 6. Looks like this one will also overlap. Here's negative 5. Here's positive 6. Negative 5 is an open circle pointing right, and negative 6 is an open circle pointing left. So negative 5 is less than, w is less than 6. I'm going to go ahead and box around my answers here. Okay, so that was 2, 3, and 4. Let's keep on going and look at some others. One thing I'm going to point out to you here. So for letter B, there's a special example there. We'll go ahead and we'll just watch these. So solving these inequalities where we have greater than or equal to's. So we have c minus 1 is going to be less than or equal to negative 5, and c minus 1 is going to be greater than or equal to 5. I'm going to add both 4's to it. So I'm going to get c is less than or equal to negative 1. And then over here, when I add 1, I'm going to get c is greater than or equal to 6. Okay? And then graphing negative 1, positive 6. That's going to be less than or equal to negative 1, and this one's greater than or equal to 6. So you're just going to write these two separately because they are OR operations. Okay? For letter B, this one actually can be written as a little bit different. Notice how whatever we get in here can be greater than or equal to negative. Okay? Everything in here is going to be bigger than or equal to negative 2. So this would actually be called all real numbers. Because absolute value will always be positive. Okay? For letter C, this one's a little bit more challenging. Notice how you don't have your absolute value alone yet. So what you're going to do is try to isolate absolute value. So I'm going to subtract 1 first. So I'll have 4. Absolute value 2x minus 5 is greater than 20. And then I'm going to divide both sides by 4 to get absolute value by itself. So absolute value of 2x minus 5 is greater than 5. Now I'm ready to solve this one. Okay, so I have 2x minus 5 is less than negative 5, and 2x minus 5 is greater than 5. All right, I'm going to skip down my page. I got some more room here. Let's go ahead and solve here. Oops. So I'm going to add 5 to both sides. So I get 2x is less than 0, so x is less than 0. And then this one, when I add 5 to both sides, I get 2x is greater than 10. So my answer, x will be greater than 5. When you graph this one, here's 0, here's 5. Less than 0 is open circle pointing left, and greater than 5 is open circle pointing right. So again, these two will be written separately because it's an OR compound inequality. They do not overlap. Okay, so just remember to isolate absolute value before you get started solving. So here are a few more to try. Again, be careful with all real numbers or no solution. So let's go ahead and pause the video here for 5, 6, and 7. And once you're done, click play to check your work. All right, so for number 5, it looks like we can go ahead and start solving. So I'm going to have x plus 3 is less than negative 8. and x plus 3 is greater than 8. Make my line there. I'm going to subtract 3. For the first one, I get x is less than negative 11. And then over here, I'll get x is greater than 5. So again, when I graph, less than 11 will be open circle pointing left, greater than 5 is open circle pointing right. So here are my two separate answers because they don't overlap. It's considered OR. For number 6, I do need to isolate absolute value. So I'm going to do that first by adding 3 to both sides. So I'll have absolute value of n plus 2 is greater than or equal to negative 3. Okay. For this one again, we will have all real numbers because absolute value is always positive. Okay. For number 7, again, isolate absolute value. So I'm going to add 7 to both sides first. So I have 3 parentheses d plus, or sorry, absolute value d plus 1 is greater than or equal to negative 6. And then once I get there, or sorry, positive 6, kind of a bigger number. And then once you get there, I can divide both sides by 3. So I'll have absolute value d plus 1 is greater than or equal to 2. Now I'm ready to rewrite my problem. So d plus 1 is less than or equal to negative 2. D plus 1 is greater than or equal to 2. Go ahead and start solving. I get d is less than or equal to negative 3. And then for my second one, I get d is greater than or equal to 1. Again, when you graph these, they will be OR because they're not going to overlap. Less than or equal to negative 3 is closed circle pointing left. Greater than or equal to 1 is closed circle pointing right. So here would be your answer for number 7. Okay, that is going to be all for our homework today, for our notes today. Just remember, for one-step and multi-step inequalities, follow the steps for solving an equation. You're reversing the inequality symbol when multiplying or dividing by a negative number. Compound inequalities, if necessary, you write them as 2 separate inequalities and then solve each separately. Include and or in the solution, depending. And then absolute value inequalities, isolate the absolute value expression on one side of the inequality, which is what we saw in number 7. Write the absolute value inequality as a compound inequality and then solve. Okay, so those are just a few reminders. If you want to write those down, you can. Otherwise, this is the end of your notes. Thanks so much for tuning in, and we'll catch you next time.